Good morning, everyone. Today we will see backtracking. It is a design technique for solving problems in algorithm analysis. There are different methods available for problem solving, like divide and conquer method, dynamic programming, greedy approach, and one of the another approach is called backtracking. We will see how it will work for solving the problems. It's a problem solving technique. It builds a solution step by step. If we move in one direction, if the path does not lead to a solution, that will stop. Again, it backtrack to the previous step. It will try another option that is called backtracking. And what's the key idea of backtracking? Try in one way, check whether it gives a optimal or feasible solution. We can take the solution. Otherwise, if the current partial solution is not able to lead to the complete solution, if it is failed, that is called dead end. That will move back to the previous step to find another possibilities. That is called backtracking. When a dead end is reached, the algorithm backtrack to the previous decision point and explores a different path until a solution is found or all the possibilities have been exhausted. Here in this type of problem, there are a number of possibilities. So the problem approach is to try all the possibilities. Here, the backtracking problem can be solved using recursive approach. Here, if it can be represented in the form of tree, the leaf node is called dead end. That will not lead to a solution. And or it can be a solution. There are two cases for leaf node. It can be solution or it can be a dead end. Where it can be used. Backtracking is especially used for solving combinatorial constraint satisfaction and decision making problems where we have multiple choices must be made step by step. So if the problem have multiple possibilities or choice or option to explore, that case we can use backtracking. How it works? Initially, start from the empty solution. Make a choice and move forward. If the current choice leads to a valid solution, continue. Otherwise, if the current solution does not lead to a feasible solution, so we can call it as a dead end. In that case, we cannot proceed further. So we are moving back to the previous step and finding another possibilities. So repeat until all solutions are explored. In this type of problem, the problem can have more than one solution. It is not necessary the problem should have only one solution. So the problem can have multiple solution. Even though we got one solution, we are trying all other possibilities to find more than one solutions. That is called backtracking. Where when it can be used. It is commonly used in situations where you need to explore multiple possibilities to solve a problem. There are n number of possibilities, n number of solutions. So we are trying all the possibilities, we are trying to find all the possible solutions. So that is called backtracking. Example, searching for a path in a maze or solving puzzles like Sudoku. And the problem requires exploring all combinations and permutations. And that is solution space is very large. So it will take more time. In that case, we can apply the concept called prune. Unwanted or the path does not lead to a solution that can be pruned, that can be removed to save the execution time. And common problems solved using backtracking. N queens problem. There are n queens. We have a chessboard. We have to place n queens in a chessboard so that it should not meet in the same line or same row or same column or same diagonal. More than one queen should not attack each other in same row, same column or same diagonal. So we have to place all n queens. So we are trying all the possibilities in n queens problem. The solution have the problem have more than one solution. For example, 8 queens problem, there are 8 queens, 8 cross 8 matrix, chessboard. There are two solutions for 8 queens problem. And Sudoku solver, fill the grid following pseudo rules. Backtrack when the rule is violated. If the rule is violated, if it is does not reveal a feasible solution, find another possibilities. Move back and find another possibilities. Maze solving, find a path from start to finish. So we are moving on one direction. If there is no path, again move back to the previous place, then find another path. Permutations and combinations. We are generating all valid permutations and combinations for the given set. And the subset sum problem, there are a set of numbers are given. We have to find the subset from the given set, and the sum of the elements, the subset should be equal to the given target sum. And brute force versus backtracking. What is a brute force method? The problem statement is implemented as such without applying any strategy or method. And backtracking, it uses a technique. It is a technique to find the multiple optimal solutions. You see the diagram, that's called state space tree. The problem solution is represented in the form of state space tree. We have a hierarchical structure. The root node is the initial solution or initial state. And the left side, leftmost node, that is a intermediate solution. The green color is intermediate solution. Again, moving back left to the left, that blue circle, that is a dead end that will not lead to a solution. Again, move back to the previous, that green node, and find another solutions that is also not a dead end. So again, move back to the parent green node. Again, move back to the yellow root node. Again, find, we are going for second options. And second option, that can be explored one more step, and we are getting the solution. That is solution node. The leaf node is either dead end or solution node. And again move back, another node is dead end. Again move back to the root. Another possibilities. There are three possibilities in the root level. And the left side, again we have a solution. See, there are two solutions for the given problem. And we are checking all the possibilities. If possibilities are over, we can stop the algorithm. And what's the difference between brute force and backtracking? Brute force, it tries all the possibilities blindly without in checking, without applying pruning concept. Here the backtracking prunes the path that won't work early. So the time can be saved. So brute force approach, without seeing any constraint, it tries all the possibilities. So it takes more time. The algorithm or the problem solving algorithm is very slower. In the case of backtracking, it's very faster, more efficient because of pruning. And brute force is not intelligent decisions. Here, backtracking makes informed decisions and avoids unnecessary work. And we will see the pseudocode for backtracking algorithm. It applies recursive approach. So function name is backtrack, solution, and we have the choices. If the solution is complete, we are getting the complete solution, process the solution or printer can be stored and written. And for each choice in choices, there are n number of choices or possibilities are available. So choose the choice one by one. Try all the choices or possibilities. If is valid choice or solution. If we are able to derive solution for the current choice, make the choice, add to the solution. Else, backtrack, solution, comma, updated choice with another choice. So undo the choice, backtrack. So if the current choice is not able to give correct solutions, remove the choice and go back to the previous option. That is the concept of backtracking. And the time complexity of backtracking algorithm, normally in the form of exponential or factorial. Backtracking that explores all possible combinations or permutations so that the time complexity is usually exponential. T of n equal to order of b power d. What is b and what is D, branching factor, number of choices at each step. There can be n number of choices. B is the number of choice, B, and D is the depth of the solution tree, number of decision made, that is D. D is depth, B is branching factor. So that is exponential growth. For some problem, n-Queen's problem, that is called time complexity is factorial, n factorial, because it will search all the possibilities, all n possibilities. So there are, if it is 8 queens problem, first queen can be placed in any box in the first row. There are 8 possibilities. So it will check all the possibilities. For some problem, time complexity is in factorial. So in general, time complexity of backtracking algorithm is exponential or factorial. So this is the overall concept of backtracking. Thank you.